Evening, everybody. Thank you for coming to my seminar on blockchain technology and what I believe is its future potential. Who am I? I'm Nabeel Younis. I graduated from Bayan 2015. Currently, I'm studying computer engineering at Boston University. My current field of research is distributed network communication protocols and cybersecurity analysis. So what I'm looking to deliver today to you guys is an understanding of blockchain technology, what are some of the fundamental components and mechanics behind this technology, an understanding of distributed networks and distributed applications and how these are based on blockchain technology, and then finally conclude with a discussion of what we can currently do with blockchain technology, what we can currently do with distributed applications, and what I believe is its future potential. So just very quickly before we start, would anybody like to take a crack at these two questions, or either one of them?
So the first one is basically a cryptographically signed record of transactions that are shared between multiple people. So the ledger is shared.
Yeah, it's a good understanding from a computer science perspective.
Yes.
What we're going to try and do is bring this more to a to a grounded perspective for people who are not involved with.
So to think of it from another way is anytime two people that don't know each other want to transfer something and they don't want to rely on a central party, you can use any kind of blockchain technology to do that.
So that's an application of blockchain technology for trustless payments or trustless transactions. But what we're going to do is explore in more detail what makes up a blockchain, and then look at how it's applied to things like cryptocurrencies or distributed applications. So this is just some sort of fundamental picture, some infographic about what blockchain technology looks like on paper. As the name says, you've got some sort of block that's connected with a chain. This is some of the underlying structure in a blockchain. So we'll explore these in the coming slides. But as you can see, the main components are the block ID, metadata, and records. And what these are, we'll talk about in a bit. But the interesting thing is that the traversal of time is actually reverse of what our normal understanding of time is. We'll do a Q&A session in the middle before going on to distributed applications. So this is a definition of blockchain that I really enjoy from Harvard Business Review. I'll just read it to you guys. An open distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. So this is so what they're trying to describe is blockchain is a system of permanently confirming records between two or more parties of people. Now we're going to delve into some of the components of what makes up the blockchain, and then these components are very crucial to understanding how to think about your business application, how to break down your business idea for blockchain technology. So we'll start with records. Records is any piece of information attached to an account. So they could be literally anything, anything that is attached to an account. So you have, for example, Alice paid Bob 1 Bitcoin, or Charlie signed document 143. So as long as you have some account, some piece of information, it becomes a record that you can permanently confirm in a block. In the metadata, we have things like the block ID, previous block ID, and the solution to the mining problem. We're not going to delve into these details too much, but it's good to know that these are involved in the metadata because that's actually what makes up the cryptographic link or the chain of our blockchain. So what are records? Records, as I said, is really any piece of information attached to an account. It can be created based on previous records or start a new chain of records. The vagueness of this definition actually covers what I believe is the breadth of what a record can be on a blockchain. It could be identities, it can be voting, transactions like we know in cryptocurrencies. So, you could attach it to electricity use, as we'll see later in this lecture. Then, what are blocks in the blockchain? Blocks is the data structure created to permanently confirm records in an indisputable, matter-of-fact way. And this is using the mining process. If you want, maybe at the end of the seminar, we'll discuss what the mining process is, but it's a fairly involved, system or algorithm. So what I think is more interesting is some of the properties that blockchain brings to any sort of application. It has inherent security by design. All the methods in any blockchain application, whether it's signing a transaction, verifying a block, the mining algorithm, how do you look up information, all of these processes involve cryptographic methods which have many years of research behind them. So they're extremely secure ways of creating and protecting data on the blockchain, and also protecting your own private information if it's your Bitcoin wallet or your identity that you use to participate on the network. But how can we achieve all of these interesting properties? It's with consensus. So before any network goes live that involves a blockchain, all the computers who want to participate on this network must agree on a preset of rules that are non-negotiable. If you want to participate, you have to follow these rules, from everything from how you package your messages to what you can actually send on the network, things like what your actual balance in your Bitcoin account is. You cannot lie about it. There's rules about how you check your balance and how you make a transaction. So I think this is there's this. So the consensus, I skipped over it because it's more of a design philosophy about what you might want to include in your consensus or what you might not want to include. And at the end of the day, it determines what sort of network you're creating and for who you're creating this network. If your consensus is extremely strict, it might be a private network, or it might limit the interactions of users. For example, like Bitcoin's consensus is very strict. You cannot send or receive anything but Bitcoin on the network. There's no sort of layer 2 messaging protocol or layer 2 contract protocol like we'll see in Ethereum later on. And so you might have heard me over the last 10 minutes or so say cryptography or cryptographic method many times. In the interest of the complexity of this lecture, I'd like to treat it as this black box where we use one particular aspect of cryptography, and they're called hash functions. The interesting property in them is that they're extremely difficult to find solutions to, but they're instantaneously verifiable. You can check these solutions as soon as you find them immediately. So trying to forge a transaction, trying to display fake information, it will immediately show up because the hash function solution will be completely incorrect. These functions are extremely random, unpredictable. You cannot guess a solution. The only way you can attack it is by literally trying every single digit from 0 up to 2 to the 256, typically. And 2 to the 256 is a extremely large number that really no computer or no collection of computers can attack from a cybersecurity perspective. So creating fake informations on these networks is extremely difficult if your consensus is designed properly. So before we move on to this, do we have any questions about what blockchain is, what consensus is, some of what records or blocks are?
So going back to what you said here, how it's extremely difficult to create fake information, and then I noticed in the beginning it was said that blockchain is inherently, like, it's secure by design.
Yeah.
So it's kind of so is it just extremely difficult to, you know, have it be corrupted or something, or is it never
Data
never be
corruption
done?
or
Yeah, so
falsification
blockchain
of
itself.
information?
So blockchain itself, it said it is secure by design.
So because all the methods in that you might have in a blockchain, like creating a record, creating a block, communicating this information to peers on the network, because they all involve cryptographic methods, trying to falsify information or send fake information is computationally expensive to a point where it's infeasible, especially if you're a lone individual with, let's say, your desktop computer. It's physically not, or virtually not possible that you create fake information, because you would have to go through an extremely large amount of computation. So, any other questions in the back?
You said in the beginning that before any blockchain can actually start, there has to be consensus between the participants in the network, right? I mean, everyone has to agree on the rules. So is it possible that once the network has, let's say, established, that there's a break in consensus?
So that does actually happen. They're called hard forks. And you might have heard about it in the news recently. Bitcoin has hard forked 3 times with Bitcoin Cash, Bitcoin Gold, and Bitcoin Unlimited. So they do happen, but the amount of work that it takes to hard fork a network is years of trying to convince people to switch over the code that they run on their computers to agree with the new rules, or with the different set of rules that might not agree with the original Bitcoin's consensus. And once you have a computer that is not participating with the consensus, by design, most distributed networks will just reject that computer. It will not allow it to participate until it starts sending messages or or its protocol agrees again with the network. So it does happen, but if your network design is good, or your original consensus design is good, then or is sound, then it should not happen often. In Bitcoin's history, it happened for the first time in 8 years. In the 8 years of Bitcoin's history, it happened for the first time in last August, and 3 more times soon after. But that's exactly the sort of timescale you're looking at. The idea for Bitcoin Cash showed up in 2014, roughly, and it took them until August 2017 to actually break consensus or convince enough people to move over. Any more questions in the back?
Thanks. You might hate me for the question, I don't know.
Adi.
But if for a minute you explain blockchain to a 12-year-old, what would you say?
So I would like to go back to the,
because the Harvard Business Review explanation.
Yeah, it's a bit.
It's not for 12-year-olds.
So it's a system of creating and storing data in an irrefutable way. People can join this network as long as they follow the rules and leave the network when they feel like it. And so it's just this way of recording history. So the definition I would give to a 12-year-old, it's a way of recording history that is not that does not have to be in any one history writer's control. You can give the pen to anybody, and as long as they follow the rules, it will be saved. So it's a way of creating an open history book, or a blank history book, if you'd like that analogy. Any more questions with over there in the back? If we could pass the microphone.
So suppose that I'm a drug dealer. Just suppose I'm not.
Sorry, could you say that again?
suppose I'm a drug dealer.
Okay.
Okay.
Drug
Just
dealer.
suppose I'm not a drug dealer. Okay. How can I use this system? So this system is for me, actually, right? Or
So you're now looking at the open ledger definition that Harvard Business Review gave earlier, where things like cryptocurrencies have popped up, and that's the double-edged sword of true financial freedom. Is you might have some people who abuse the network for malicious or unlawful activity. But the interesting thing is when you read Satoshi Nakamoto's original the original paper on the subject, is he talks about, yes, there are going to be people who use this for unlawful activity, but that is not the true majority of human nature. So on a global scale, the majority of transactions are hopefully going to be legal and lawful.
so because there are so many ways that you can do a transaction, why, if you have a clear transaction, why you use something like that so encrypted and so secret?
So this is now a question of privacy and how much privacy you'd like in your life. Right now, anything you do, opening a bank account, opening a Facebook account, you give up things like your email address, your home address, your social security number, or your بطاقة مدنية, the civil ID number. And certain parties might not need this information but are asking for it anyways because they may monopolize the market. For instance, Facebook, they know too much about you, and they're able to directly sell your information and or advertise or target to advertise you. So the interesting thing that something like a blockchain does is you as a participant control exactly how much information you want to tell the network. And then when you feel like you don't want to participate anymore, all you have to do is stop running the code. And nobody can send or receive or bother you about why are you online or not. So it gives you full control over your information, your identity, who you interact with, who you want to or not want to interact with. But these are things that is case-by-case specific on what network you're participating in. Bitcoin's network has different interaction rules. Ethereum's network has its own set. There are other technologies that we're going to talk about later, like Grid Plus, which we'll get to, has its own ways of what information you give to the network and how you interact. So this is a consensus. This is a consensus design question. I hope that answers your question. Any more questions about blockchain or consensus design? No? Okay. So now we'll talk a little bit about what distributed applications and distributed networking is. Just from a infographic perspective, it's what you see right here. A distributed network has no central authority versus something that you might see like Uber, which has this centralized authority that facilitates all of your interactions between riders and drivers. Whereas a decentralized application has no facilitator, because the facilitation is done by consensus. So before you join the network, you agree to the rules, you agree to how you will participate, because you are running code that agrees with consensus. So by default, if you're on this distributed network, then you agree to the terms and conditions, you could say. Some interesting differences between centralized and distributed networks. In centralized networks, you have centralized authority. And usually users have no say in the development of the product or service that they are receiving from this company. For example, if you wanted new or different features on Facebook or Uber, as a consumer, you have no say in what happens. Whereas if you're on a distributed network, then most of the time it's open sourced, or people are involved in in the development process, because at the end of the day, how are you going to get people to join your distributed network? It's by offering features that they want to use or features that they agree with that should be on your network. In centralized networks, we go back to how much information you want to give up. In centralized networks, typically that means you give up private information versus a decentralized network where you control what information you give, or you give no information if you can write your own code, for instance, to join the network. And then interactions in centralized networks tend to be censored or limited by the company for whatever reasons they feel is within their jurisdiction, whereas in decentralized networks, the only limitation is the consensus you agree to. So if consensus doesn't let you do a certain thing on the blockchain or on the distributed network, well, that's something you agree to by joining this network. And if you don't like this limitation, then you should try to find a different network that more suits your wants and needs. So the interesting thing you can do with decentralized networks is create decentralized applications. This is a fairly new term. I haven't seen it pop up really in any newspaper or journal, but they're called dApps, decentralized applications. And what they do is they take any existing product or service that you might know of and remove the middleman from the interactions between the consumers, the providers and consumers. So for example, going back to the decentralized Uber example, what you could do is create, or you could design a set of rules, a consensus, that allows people to join the network and request rides and show themselves as a driver on the network. So what you could do is you could allow drivers to create parameters about, okay, let's say if I'm a driver and I'm driving a limo, I want to price myself differently according to my fuel expenses, my convenience of being a limo, versus somebody who's driving a Toyota Camry. That's the interesting thing you could do with decentralized applications, is you basically allow markets to become directly consumer to provider rather than consumer to facilitator to provider. And I have an interesting example coming up later about what Kuwait could do with decentralized applications. So what do I believe is the dApp's future potential? Is it will fundamentally most aspects of your daily life involves going to the bank and opening a bank account and registering with the bank, or going to your school and submitting applications. But with dApps, you're no longer restricted to what bank do I have to go to, or what or what information do I have to give to people. All you have to do when you want to open a bank account, let's say with Bitcoin, is you just create your wallet, you announce it to the network, and you've instantly joined this global global marketplace where people can buy or sell whatever they feel like. It's a sort of strange idea to talk about, because all of our interactions currently are facilitated through governments, institutions, banks, and to create applications that remove these institutions is not inherently obvious, but it is the direction we're moving in. So the first wave of dApps is already upon us, and they're called Ethereum smart contracts or tokens. Just a general show of hands, has anybody heard of what tokens are? Few people in the room. So tokens, what they are is they're this smart contract that is layered on top of the Ethereum blockchain, that is not connected directly to the currency, but you can use the currency with it, and it allows people to attach value to these tokens and exchange them with other participants on the network. Sorry, I should have defined what a smart contract is. A smart contract is literally any piece of code attached to an account that triggers during given conditions. If you wanted to Google about this later, you would just have to Google ERC20 standard. That's the standardization for tokens on the network. Sorry? Ethereum is another cryptocurrency. It's the second largest cryptocurrency by market capitalization right now, or third. Second. It moves every day. But the interesting thing with Ethereum is it has this layer 2 protocol. It allows you to build applications on top of it, although which is one of them is tokens. We're not going to delve too much into what Ethereum does extra, but I want to use tokens as an interesting example of a decentralized application where we don't have to think about network protocols or how to join the network, because you just join it like you're joining Bitcoin or Ethereum. You just create a wallet and you're automatically ready to send and receive these tokens. We'll get to questions in a minute. So tokens, what my definition of a token is, a token can be created by any account and it can be issued to other accounts. So I could create a token called Nabeel token, which is worth 1 hour of my work or my time. And I can issue it to people if I owe them work, and they can redeem it when they feel like I should be working for them. For instance, another one could be petrol tokens, which are issued by a state as a subsidy for gasoline. So people, let's say there are people who have Hummers or race cars, and they're constantly, burning gasoline whenever. They should not be receiving as much subsidies as farmers who have to drive their truck from the farm to the city and back every day. So what you could do is have a state issue tokens to everybody every month in a more discriminatory way, but it's a good type of discrimination. And this creates a fairer distribution of subsidies according to that individual's wants and needs. So, people who are just driving their cars for pleasure should not be receiving as much subsidy as the farmer who needs to get his produce to the city and back and who's driving probably a rather large truck. Another type of token could be a Sirdab Lab token for members who there's certain benefits to being a member, and instead of having a ledger where people have to, whereas Zainab might have to go and look up, oh, is the room available for you or not, or have you used all of your coffees for the month or whatever, you could just issue tokens and automatically spend them when you want your benefits, and it's all kept track on the blockchain automatically, and nobody has to do extra bookkeeping. So an interesting token on the Ethereum blockchain right now is called Grid Plus, and it's an energy sharing token where that allows homeowners and businessmen and small businesses that have solar powers and batteries to automatically send and receive electricity to each other. And so you can see this is a decentralized application for power generation. So instead of having a central power plant that's burning fossil fuels or that's a nuclear reactor, if everybody had a solar panel on their house and a battery that is being charged over the day, when you're not, let's say you go to sleep and there's a business that's using energy 24/7, you could automatically sell energy to that business, while you're sleeping. And then you have a party one night and you need extra energy, you could automatically purchase extra electricity using tokens in your reserve. Based on how much you've sent, you can receive an equal quantity. So the company that's currently doing this, Grid Plus, they're in Texas right now. They don't make money in the actual transactions of tokens. They actually make money by helping you set up your house to send and receive energy, which is not something any normal house infrastructure does. So if you're trying to think about your decentralized applications, revenue stream or where you're going to make money, it's not necessarily in transaction fees. For example, there are no transaction fees on this network. People send and receive certain amount of tokens based on the kilowatts per hour and stuff like this, whereas they make money by helping you set up your house infrastructure. So I thought this was a very interesting example for Kuwait that has probably the hottest country on earth, and all the space in the world to put solar panels everywhere. And sorry?
All the miners are going to be buying the tokens.
The tokens? Yeah. No, the thing is, tokens you can't buy them on this network. This is also They need electricity to mine. Yeah, they're going to be spending all of theirs. So another example would be, for example, let's say we had this website called abiaklat.com. And it's a website that allows you to order food and they'll deliver the food to your house. So instead of having it be facilitated through this website that charges restaurants to use it and charges the end users to use it, why don't restaurants agree on a development team that will allow people to directly order to restaurants food, and they pay automatically with cryptocurrency or cash on door or whatever they want. But the interesting thing is you're not going through this middleman for placing your order. Your order goes directly from you to the restaurant, and then you could involve third parties. So instead of having drivers who are paid by a company to be on standby and drive around, you could have an Uber-style delivery system where there's three parties. You have the customers, drivers who are waiting on standby, who are just regular people who have extra time, and then restaurants who are waiting for orders. So because of Kuwait's large food industry and also the food delivery industry in Kuwait is really picking up in the last few years. Moving to a decentralized system is very cost effective for restaurants because they're not paying these huge fees every year to be on something, on one of these delivery apps. And it's also more cost effective for consumers because all they have to do is pay directly the restaurant, whatever that is, without any sort of service charge or service fee. As long as you're running code that agrees with consensus, you're able to participate on this network. Before we get to this is probably the most frequently asked question I've ever gotten when it comes to technical stuff with Bitcoin, but we're going to hold off on this question for a little bit. This is sort of the end of me speaking, but I know the crowd probably has many more questions that will delve into some of the more interesting aspects of blockchain technology and distributed applications. So for the next hour or so, it's the floor is to questions. Like this is the presentation. We'll just start taking questions and have a conversation going through. So we have a question in the back that's been waiting.
So Bitcoin uses the blockchain system, right?
Yep.
Okay, so as you said, there is no central party. So when I put my documents, my civil ID, my passport in the Bitcoin wallet, for example, is it safe? Who can see my documents that I post on?
So that's exactly the type of information control that I was talking about. I want you just to narrow down your question a little. Are you talking about when you want to open an account with an exchange to buy Bitcoin? Is that what you're trying to describe? So this is exactly what we're trying to get away from with centralized applications or centralized services, is they require all this overhead from you in terms of private information for you to participate in whatever service they're offering. There's companies like Coinbase that will request for your bank account details, your social security number, a photo of you, and a picture of an ID as well. This is only because the technology is very immature. Trying to get people to join in any other way than... If you're buying Bitcoin on Coinbase, you're not participating on the distributed network. They are participating on the distributed network and then sending you money on the side, or Bitcoin on the side. But they are not that's not participating on the network. What participating on the network would be is running a dedicated computer that runs, for example, Bitcoin Core. It's a piece of software you can download. It downloads the blockchain for you and allows you to make transactions by yourself. You set your own transaction fees. You don't have to give any information to run this program. You just generate your address and you start participating. These sorts of exchanges, these are not part of the blockchain. You can think of them buying Bitcoin from the network. That's one node. But all the exchanges that happen within their service is completely, it's called off-chain. It's not really anything to do with the centralized blockchain. Question here in the middle. We'll just wait for the microphone.
What differentiates the networks from each other? So everyone here in the room can develop a network for these restaurants. What's the incentive for a restaurant to join your network and not mine?
It's all about your consensus design. If you design rules or you design parameters that more people enjoy or more people agree with, then they will just run your code and not your competitor's code. It's literally a computer voting system. What code is the computer running is how people vote, essentially. So if you design, let's say your transaction fees in your network were very high, or your throughput, your orders per second. This is an interesting number, which is why Bitcoin is very expensive right now. Bitcoin's current throughput is 14 transactions per second. PayPal is 700 transactions per second. Visa, on average, is 25,000 transactions per second. So if your network, and this 14 transactions, this is purely down to short-sightedness in consensus design. So if your design in 2017 is able to handle 20 transactions per second, but when average network traffic becomes 50 or 100, changing the rules to increase your capacity, this is an extremely difficult process. And this is why we have these hard forks recently. So it's all about your consensus design, what network you join. And then there's a question in the back still? Yeah, afterwards, yeah.
Thank you. How do these networks verify my identity? And is it safe and is it legal?
So what aspect of your identity are we talking about? Are we talking about your identity on the network or you as a human being?
Both.
So
because identity gives some kind of safety. When they ask for the passport, for the photo, this gives them and gives me.
So the previous question was talking about participating on an exchange, which is a service that they're trying to give you. You know, that's a service trying to give you Bitcoin, and this is the information they require for certain reasons. The legality is country by country. But that's because you're trying to participate with a centralized service. If we're talking about participating on a distributed network, something like this, to join it, all you have to do is generate a public address, which you can do privately, offline, with no information about who you are, and then announce it on the internet. But when you announce it, there's no information about who you actually are. You run a small piece of code by yourself. It creates an address, and you just announce it. So there's no way of taking this address and attaching it to your name.
What if somebody else uses the same address, for example?
So
how do they know who these people are?
So the only way they could use the same address is that there's certain private information that you use to create your public address. Mm-hmm. This private information should be, it's like a password. It should be very strong, something that's maybe 30 or 40 characters, and you write it down on paper, and you just want to hide it somewhere.
So it's not an actual address. It's not my actual address.
No. It's like a. So when I say address, mm-hmm. it's an address that you put on the internet, mm-hmm. that people, if they know it, they can send you money or receive money from you. Mm-hmm. But can they sign transactions? No, that's private information sitting mm-hmm. Somewhere, very secure, hopefully. Okay. But just one more time to hash over the giving up private information. If you're doing this to participate on a blockchain, it's probably because you're using some sort of centralized exchange. You know, Coinbase mm-hmm. Coinbase looks very much like this. Mm-hmm. And then they bring in currency from the Bitcoin network. Mm-hmm. Whereas Bitcoin's network actually looks like this, where there's no central authority and most users are almost completely anonymous.
Okay, thank you.
We have a question in the back, and then we'll bring the microphone up here.
So because the network is anonymous, any activity on that network can only be tracked as far as the Bitcoin or the network addresses is concerned.
Yes, correct.
And then it is up to you to secure that network address based on the key that you use to.
Yeah, this is your seed generation.
Right.
Hopefully, it's strong enough, and you just write it down
somewhere. But on the network itself, the work that's being done, it doesn't have any monetary value. Is that right?
What do you mean? Could you say?
For example, they always say that it is very easy for people who are doing illegal activities to.
Oh yeah, so all transactions have no sort. So
Yeah.
the amount of information attached to your transaction on at least Bitcoin is as much information as you want to add to the transaction. You could have as little information as address A paid address B 1 Bitcoin, and that's it. People would just know that this public address now has 1 more Bitcoin. So if we want to go back to the page. So, for example, if you think of Alice and Bob as 2 random addresses, 2 random just string of letters and numbers that is your public address, all you know is that the account, the address that is called Alice paid the address that is called Bob 1 Bitcoin. You have no information about whether it was for groceries or for a mortgage payment or if it was a loan or not. The amount of information you give to the network is completely within your control. We have a question up here. And then we'll start queuing questions. So question here in the gray suit, and then back in the gray sweater.
Thank you for the presentation. Obviously, you're saying to participate in this network. Yes, it's true. For me, I only understand there's only 3 ways to get Bitcoin. 1, you mine, either directly or through a slush, through a
mining pool. Yes.
2, you go to an exchange and you buy it somewhere.
Yes.
Or 3, you actually sell something and someone actually pays you in Bitcoin and you have a wallet to receive it.
Yes.
Those, for me, the only 3 ways to actually get started and actually getting involved. The first one was the most popular, is actually you have to go through an exchange, so you have to give all your documents.
This is because the exchanges that you're aware of are these centralized exchanges like Coinbase that deal with the US government and stuff like this. There are other exchanges like localbitcoins.com. They're a website that's peer-to-peer buying and selling, and the amount of information you put there is only your public address, for instance. And as Bitcoin becomes more and more popular, joining the network will be more simpler, where you go to your local currency exchange branch and you can do a private payment like that. I think because of Bitcoin's current rising value, that's why joining the network is very expensive, or purchasing Bitcoin is very expensive. Okay, let me restart this. You're right about central exchanges being the most expensive way or that they're the only way for most people to join the network. But they will not be the only way. When the technology progresses, either we use a different mining algorithm that anybody can run. Ethereum's mining algorithm uses a proof of stake, for instance, not proof of work. And you can run that on your Arduino board or your mobile phone to join the network instead. So it's because of how immature the technology is. Some of these aspects of mining and how you distribute currency to users and stuff like this has not been flushed out completely. But as we move forward in research, we are developing fairer ways of joining the network that is based on either letting your computer run code that or mining with your computer, and then at some point there might be this mass migration of fiat currency to US dollar, where everybody over 2 years just all of a sudden completely puts all their cash into Bitcoin, maybe in 20 or 30 years, and then it just whoever had that amount of US dollar now has that amount of Bitcoin from whoever was selling it, and it almost becomes as if we were never using US dollars and we were using now a cryptocurrency. No problem. In the gray sweater in the back, and then the gray. Oh, sorry, we'll get around to it. So there's the girl over there.
A lot of people say that, critics say that with the lack of a middleman, there's an absence in regulations and a regulator. So would you say that you can't really hold someone accountable if something goes wrong?
I'd like you to narrow down your question in terms of what is something going wrong.
That's the thing. It's new that we don't really know what's gonna go wrong, even with decentralized app. If that is a possibility and stuff would go wrong, would you say that there's no regulator, there's no
So
someone?
the regulator, the facilitator, what I'm trying to emphasize is facilitation is by consensus. So if your rules about how to participate on the network are sound to a degree where stealing money or falsifying information is extremely difficult to do computationally, then your network is secure. And the way information is recorded to the blockchain with the mining problem, to try and create a fraudulent transaction or lie about something on the network, it's extremely difficult. And if you have a misbehaving computer on the network, typically whoever that computer is connected to is just rejected. The connection is just rejected. But accountability. Yeah, do you want me to talk about accountability?
But my question is in reference to the decentralized apps, like with the
Oh,
consumer and the...
Okay, so who's responsible for development or who's responsible for network failure?
Yeah, exactly, network.
So if the network fails because of some critical code bug, that's because of the development team. If the network fails because people are not participating, there are not enough live computers operating 24/7, that's because of consumers not being interested in this decentralized application. If something goes wrong, what it is, it's a case-by-case basis. So we could talk later about what your specific idea of something going wrong is. If we could pass the microphone over here in the middle. And then who also had questions, if we could raise hands. So 1, 2, 3. Okay, we'll get around.
Okay. So my question here is, when we talk blockchain now and decentralized networks, mainly we are talking about bitcoins and cryptocurrencies.
So cryptocurrency is an interesting application, or it's the most obvious application.
The most obvious, yeah. So, and that brings us to money. When
Yeah.
we talk money, we talk banks. So how blockchain can be into banks? Because banks, when we say banks, that's centralized. Blockchain, it's mainly for... Actually, there's one question before this. Blockchain, this is attached to the centralized network, or blockchain as a technology, I can use it with centralized or some kind of...
So the blockchain it's considered a data structure. So it's not a database, it's a data structure that can be maintained across many computers simultaneously. If we go to my properties slide. So as you can see here, it's a data structure that can be maintained by thousands of computers simultaneously.
So for example, if I have a network of banks that have that ledger between them, okay, so we can have that blockchain for money between banks, which is, it's distributed by the bank's perspective, but for us, still it's banks, it's like one centralized place.
Yeah, so if you end up having any sort of single point of attack or your user base is extremely small, this still is considered a centralized network, just on several computers. When we talk about decentralized networks, we're really saying something in the magnitude of thousands of computers that non-technical consumers, somebody who's at home who just wants to join this network can run code on his computer.
But it all depends on the perspective. So for example, when definitely you heard about the Ripple, let's say,
I've heard
platform,
of it. Yes.
which is like there to facilitate the international, let's say, international transfers. So if all the banks around the world join that Ripple platform, for example, that means there's something blockchain and ledger and a decentralized, let's say, network between the banks worldwide. But again, as a consumer, me, a simple user, I still see a bank.
You still see a bank, but that's because you're trying to still participate with a bank. If you're working on Bitcoin's cryptocurrency on that network, it doesn't have any space for some sort of central authority like a bank that holds your currency. In Bitcoin, your private address allows you to access your currency directly by yourself. You don't actually store some piece of data that says you have 1 Bitcoin. No, the network agrees that your public address owns 1 Bitcoin.
Okay,
and when you want to spend it, you announce to the network, hey, I signed it with my private signature. Let me spend this Bitcoin. So you're not, when we say cryptocurrency, you cannot think about coins or cash that's sitting in a bank. No, you have to think more of there is a piece of data that says my balance, and it's just a number. But how can you spend that number? How can you spend from that number? Is with the signature, which is your address.
But I still can use the blockchain and the ledger to, because
you could run a bank on a blockchain if you wanted to.
If you can go back to the blockchain, the block design it was, or the component of the block.
Okay.
You said that it could be, for example, Alice paid Bob 1 Bitcoin. What about Alice paid Bob $1, for example? Still, right?
If you want to, you could record. You could record events, real life events, like Charlie signed this document, which is a physical world thing. You can record it on a blockchain, and as long as your event, the event you want to record here, or the event you want to record here, as long as if it's in this block, then it means it must have happened after this block. So you're now looking at blockchain as a recording method, which is exactly what Harvard Business Review's definition says. If we look at here, an open distributed ledger that can record transactions between two parties. So the transactions are not Bitcoin. The transactions can be US dollar, can be these Grid Plus tokens I talked about, can be the subsidy tokens I talked about. It's really open.
Thank you.
Question number 2 here, or number 3 here, this pink sweater.
I got 4 questions, so I hope you would have the patience.
Yeah. Well, okay.
First, I would want to know the difference between hard fork and soft fork.
Okay, so a hard fork is, we'll start with soft fork. A soft fork is a change in rules that does not fundamentally affect, that does not fundamentally change the consensus of the network. So what could happen is if users wanted to participate in the soft fork, it's still backwards compatible. Users who participate on this soft fork also participate with the main chain, and there's no consensus disagreement. There's just maybe a different way of signing the transaction. So signature transactions, you might have heard of SegWit recently. Yes. Instead of signing the transaction and putting it in the block, you can sign the transaction off-chain, and it's still acceptable.
So SegWit is considered soft fork.
SegWit, is a soft fork.
Okay, so hard is
a hard fork would be, for example, with Bitcoin recently, changing the block size from 1 megabyte to 2 or to 8 or to 32, depending on what hard fork you're looking at. Because this does not agree with the mining algorithm, we had to fundamentally change the mining algorithm for the new block size. And because those two things don't agree with each other, that's a hard fork. So anybody who's creating blocks on this new block size, it will not agree with the checking algorithm on the old block size.
So would we say that Light Bitcoin basically has a better infrastructure in terms of
What do you mean by Light Bitcoin?
Light Bitcoin is one of the coins that is way faster than Bitcoin in terms of transaction time.
It's Litecoin, not
Litecoin. Sorry.
Yeah.
So,
repeat your question.
Yeah, Litecoin actually is by far more developed when it comes to the infrastructure involved in that sense.
So Litecoin has a different design philosophy. The thing with Litecoin is because the block time is so short, it's much easier to attack because the amount of work you have to do is only seconds of work, whereas Bitcoin requires 10 minutes of work. So to try and change the blockchain significantly with like 6 or 7 false blocks requires an hour of work, which on a network moving that fast is too long for you to try and create something malicious. So that could be a huge security issue with fake blocks being generated too quickly for the real network to differentiate between the fake and the real.
Possibly because it's less traffic as well on the Litecoin.
Yeah, Litecoin's transactions per second are not as heavy as Bitcoin's network traffic. But that's all things that research like mine we're working on increasing the throughput and having things like off-chain transactions, for smaller payments be a thing, to try and decrease the global network pressure, and confirm transactions faster and stuff like this. So this is, because it's such an immature technology, lots of this stuff is still in research, and there's also different mining algorithms, like Ethereum's proof of stake algorithm. That's a really interesting one. It's a finite state machine style algorithm, but that's
actually my next question.
What is
the
it?
difference between proof of stake and proof of work, I think?
Yeah, so
What's the difference?
proof of work, basically, that means we're going to start discussing what the mining algorithm is like. So let's go to that slide. It's not flipping, whatever. I'll just start talking about it. So the Bitcoin's mining algorithm, what it is really is, you take the entire block, or you take a bunch of transactions, and then you put it through a hash function, and you want the hash function to produce a certain output. Trying to guess this output is extremely random. Actually, let's use the board. This will be much easier if I just draw a little bit. So basically, what happens is you take a bunch of transactions. Can people see over there in the corner, or should I turn this a little bit? Oh, sorry. So you take a bunch of transactions, you put it through some fancy black box, which is called the hash function, and it outputs an ID, the block ID, essentially. And this ID is typically a bunch of zeros with some numbers like this. This is like 256 digits. So it's a fairly large number, and trying to guess the output of this function is not feasible. So what a proof of work algorithm is when you take this block of transactions, you add a number to it, put it through the hash function, and then try to get the desired output. So the only way you can get your desired output is by trying 0, 1, 2, 3, and so on, until you hit numbers that are in the trillions of trillions, and that's roughly 10 minutes of computation time. So that's a proof of work algorithm. A proof of stake algorithm is based on something called finite state machines. I don't think we're going to talk about it too much, but basically it's similar to a proof of work algorithm, but it's only for your specific account. So you generate a new you generate a solution that takes less time, but it's only attached to your account, if that makes any sense to you. So you're not trying to change, you're not trying to confirm something on the whole block. No, all you're doing is changing your solution, your mining solution, to your specific account. So it's a state change, if that makes sense. Yeah. We can talk about this in some more detail, but we need paper.
It's pretty clear. It's just faster.
Okay.
Moving on to the next question is basically the development side of blockchain. How is it getting traction all over the world? Do we have like developers of blockchain developers?
Yeah, so the development community for blockchain, the nice thing about it, because it's a decentralized system, is most of these projects are open sourced and have contributions globally all over, by researchers, by developers who have an interesting idea for a feature, by people who want to work on this on the side. For example, my work is in transaction synchronization. So all I did was find the source code for Bitcoin, look at what sort of communication protocols we have for transactions, and see, okay, how can I take this protocol and make it more efficient? So anybody can participate in the development of Bitcoin, but there are people who contribute more, who have established online identities, like historically Gavin Anderson. He was a long-time Bitcoin developer from 2011 to 2014 or 16. And most of these tend to be open source projects. And that's how you also gain traction, is because people see your code and can verify and prove its integrity, people will want to join your network.
So yourself is one of the developers, you call yourself?
I wouldn't call myself a developer. I'm a researcher on distributed networks. And my work, or what I'm aiming to improve, is this particular protocol. So we work on really small things, but when you have thousands of people contributing every day, making many small changes everywhere, you get mass progress very quickly. That's why this technology has developed so much.
Excellent.
I think we'll move the microphone to this gentleman over here and then in the back.
Thank you. How do you see the future of the platforms? Is it the Bitcoin platform or is it the Ethereum or?
As a market or?
As a use for the mass.
Oh, as consumer use.
Yeah. I mean, which one will prevail?
Which one will prevail? I think what will happen is there will be several that will prevail, and people will treat them slightly differently, each of these cryptocurrencies. So you might see Bitcoin become people's gold reserve, and Ethereum might be the one you use for coffee every day, and Litecoin might be what you pay for, you give your kids allowance with. And we're developing systems called atomic swaps, which allow you to exchange between different cryptocurrencies. So what I really think it will be is something similar to our banking system, where we have asset classes and ETFs and cash and commodities, but on several different networks. And you know how many networks you want to participate in. If you want to have a complicated, diverse portfolio, you'll be joining many networks. If you just want to buy your coffee every day, you might be on just one or two of them. So each of them have their own use cases, and it will be some sort of evolutionary progress, this technology. The ones that are really not useful will get weeded out, and nobody will buy or sell it or accept it in their stores, and the ones that really have value or are interesting for people to use will move towards being the currencies of the future.
But don't you think that new altcoins that are improving on the system of the networks and are trying to to overrule the old?
This is just like any technology development. Early computers, in 5 years they're completely destroyed by newer computers that are faster, more capable, have more storage.
So will the Bitcoin still be there, or it will?
So the difference with Bitcoin is the development team behind it is unrivaled in the blockchain space and the cryptocurrency space. These are really the most innovative developers and engineers in any cryptocurrency space. So Bitcoin will be around for very different reasons because of its development team. Other cryptocurrencies will succeed or fail based on their use cases, or they will have things like tokens, like I described with Grid Plus, that are for energy exchange. Where's the Grid Plus token? So you will see a marketplace that has several cryptocurrencies participating together, not one central. So that's also a thing. You will not see just one cryptocurrency at the end, because that would be centralized in some aspect. That would be some sort of centralized network at the end. We have a question in the back. If we can get the mic. Sure. Who else has questions? Just a quick show of hands. We have one, and then we'll come back.
Yeah, so my question is, for those who are thinking or are investing, long-term holding, that sort of a thing, do you think the government will have a positive stance or a heavy regulated kind of position towards in the mid to long term? So
Bitcoin, or not Bitcoin, any sort of decentralized network based on a blockchain, because it's decentralized, there's no single point of attack, and the type of internet traffic, if you look at it at the bits level, is indistinguishable from your Facebook message, from your FaceTime call. So there's no real way to stop this sort of network unless you just shut down an ISP.
The internet, or heavy regulation.
Yeah. If no ISP that I'm aware of can actually filter content or check your content unless they know exactly what website you're trying to access. But if torrenting has been around for decades and nobody has stopped it, because this is peer-to-peer communication, you cannot distinguish it from one type of data from the other. It doesn't work like that. So as far as regulation goes, it might be how easily can you convert your Kuwaiti dinar to Bitcoin. But once you're past that barrier, you're home free. Nobody can stop you after that. Nobody can...
Home run.
Home run. There you go. We have a question up here, and then we'll go back. Here, front row.
Okay, so you might not, just an opinion I'm asking, okay? But Bitcoin basically has a finite number of coins, which is 21 million.
Yeah.
We are now about 16,700,000 in circulation.
Million, yeah.
Which, and the rewards actually going to half every 4 years.
Yes.
Which will be fully distributed
So
around 2040, something like that.
No, 2140.
2140s, yes, correct. So what is your opinion when the currencies, when the supply is fully mined, first of all? And because a lot of the miners actually get transaction fees based on, and prioritize that according to how much they get paid, how will they be incentivized, or how do you see it evolving once it's a fully mined currency? Because it'll be the first one.
So the interesting thing would be to read Satoshi Nakamoto's conclusion, the white paper from Bitcoin. The author, his name is Satoshi Nakamoto, his pseudonym. In his conclusion, he envisions by 2140 we would have had a better currency solution. So it's not really a question. I've not seen any debate of what we will do after cryptocurrencies, but definitely there will be some sort of legacy effect of this decentralized ledger. But will it be a cryptocurrency in 150 years? Not up to me.
And my last question is, you mentioned proof of work, proof of stake.
Yeah.
Are you aware of any other algorithms which are gaining traction, such as proof of space and time?
I've seen them around, but they're not really a part of my research. I've not looked into them too deeply, but if you want to talk about it later, I'm sure we can
thank you very
sort
much.
something else. We have a question here, and then any more questions on this side? Next.
Thanks. My question is on the efficiency of the network over time. You mentioned that there's every block records like there's a record of all the transactions that happen in the network, and it's cumulative, right? So doesn't the accumulation of data into every block of the network require so much of computational power, and that with time will mess up with the efficiency of the network, or at least slow it down?
It's a current problem we are tackling. I attended Scaling Bitcoin 2017, a conference it was in San Francisco a few months ago, and this was one of the main questions. What is our scaling propositions? Right now, Bitcoin's network, the amount of storage we use is about 1 megabyte every 10 minutes. And the amount of electricity behind it is equal to the bottom 150 countries of the world put together. And the equivalent of of Haiti every year is being added to the network every day. So Haiti's yearly use is being added to Bitcoin every day. So there's this huge sustainability issue ecologically and from a network maintenance perspective. So there is progress. Things like proof of stake algorithms are definitely a direction people should be looking into, but that is also a hard fork on the Bitcoin network. So in terms of sustainability, at least within the next 10 years, apart from the electricity use, it should not, storing 200 gigabytes on several thousand computers around the world, that's not something we're not good at. It's pretty cheap in terms of space. And who's taking the real cost are the miners, but that's a limited amount of people. As a consumer, you will not really feel these effects apart from transaction fees. I hope that answered your question.
It does. Thank you.
Yeah. And then we have a question here on the left, if we can pass the microphone.
Hi. My question is basically, it's more about like a future outlook. What if our central banks or like a country decides to embrace cryptocurrency or like blockchain?
So there is actually a project that's supposed to be starting in 2020 with Dubai government. They're looking to to move all of their public record management to blockchain style systems, things like land ownership, civil ID or identification management, police report filings. There's a company called Consensus in the US that is the consultation company for this project, actually. So it's an interesting project coming up in a few years. If you want, I can show you the links later and we can talk about it. No government is adopting it yet, but this is the first project I heard of that is looking to adopt blockchain as a government regulatory process and as an accountability process, transparency. So
My question also is, let's say a country decides to take that as their main currency, or like that country, like that's their, for example, instead of dinars, we'd have bitcoins.
Okay.
What would that affect our monetary policies?
So in terms of monetary policies, you can no longer, have things like, what are they called? Not bans, but you know how, for example, you might not be able to pay somebody something, or I forgot what they're called. Really, what it does in terms of monetary policies is you can't stop people from spending money on things that the government might not agree with. You cannot also regulate how much money is sent in and out of the country. So for instance, China has this problem. You're only allowed to send the equivalent of $50,000 out of China every year. But with Bitcoin, big businessmen and, they're able to send much more money out of China, whether it's to their offshore bank accounts or whatever, through the means of Bitcoin. So in terms of regulation, it will be trying to, governments might be trying to find a way to identify what addresses are to their home country. But further than that it's extremely difficult. Ultimately, you will not be able to regulate where you can send money, who you can send money to, how much you can send. These are not things you can regulate. You might be able to sort of have a taxation system where you privately tell the government, hey, this is my address. But as long as your payments are anonymous, they can't stop you on that. You can just pay your income tax if the government does it really well. But I doubt that will even be a thing. Like that's a politics issue. We can talk about it if you want later. We had who was the other question? Again, in the back.
First of all, thank you very much. It's very interesting. Not just a question, but more of a comment and clarification. Someone asked about regulation in Kuwait. I work in a bank in the electronics banking department, and so as far as the Central Bank of Kuwait is concerned, Bitcoin is under their radar. They're watching it very actively. What happens? They have given banks specific instructions regarding Bitcoin from the Central Bank of Kuwait as the regulator. However, I see the more important application will be for the distributed ledger, rather than the concept which is more lucrative is the money. I mean the monetary value of the coin itself. It's coming now. I mean, I'm sure you know there's 2 banks already in Dubai that are already using Ripple to do transactions. And so I think for banks, the idea of a distributed ledger makes sense because it reduces the time it takes for anyone to make payments to anyone else. So right now, if I were to transfer you money, it will take minimum 1 business day and maximum up to 4 business days if it's an international transaction. With something like a distributed ledger, it'll take seconds, literally, for me to give you money. And that's actual...
that's time saving and
that's time saving and cost saving issue. So I think the blockchain will really, the ledger part will be really good. As far as the monetary value of it, I think where governments will regulate is the exchanges. Like right now, it's very difficult for me to actually sign up to any exchange because they don't allow people from Kuwait to sign up to any exchanges. So getting onto that exchange, so where you can take regular money and then participate, or let's say trade in Bitcoin, or to pay someone in Bitcoin, that will be the area where I think they will regulate. But as you said, they cannot regulate the network itself.
But that's going back to what I said earlier. Once you're out of this fiat currency space, once somehow you've gotten yourself to be completely, completely cryptocurrency based, then there's really not much they can do in regulation. Right, unless they have an identity attached to your public address, then this is...
No, the problem is not for anonymous. The problem is, okay, I'm not doing anything illegitimate. I legitimately want to use Bitcoin. I'm not doing any nefarious transactions. But if the market doesn't accept coin, In the other hand, if coin is not a legally recognized tender, which is what the word is, like you cannot use coin to settle debts, then it won't reach that level where it's being used practically every day. So because in the end, all businesses have to convert that into something that's legally tender. So if I pay you in Bitcoin, you cannot go and pay your car settlements in Bitcoin, because the car dealer right now doesn't accept Bitcoin. So eventually you'll have to get out of the Bitcoin space into the currency space, and currency space back into.
That's now an adoption question, and how do you want people to participate on this network? Not really my field of work, but it's an interesting question to think about, especially if you're trying to set up a business. You want to think about what your consumers, how do they actually have Bitcoin? Can they pay you? There are challenges that people are working on currently. We have a question in the back.
With the growth of Bitcoins and this electronic money, do you think that this will result in collapse in banks? So we don't need banks anymore, right?
That doomsday image of banking systems and governments collapsing because nobody's choosing to participate on that system. I don't think that will really happen as long as there's some sort of dependency as a human being on your government for security, for subsidy, for travel. As long as you have this dependency with your government, that will never happen. If governments fail, if the governments become obsolete because of some decentralized network, then you could think about that dystopia, but I don't think that's the case.
I mean, you use a bank to save your money or to send your money to other participants, or I don't know what will be use of banks in age of electronic money.
Exactly. It's a trust system.
Yes.
I think we'll move away from how we use Bitcoin and more about let's try and keep the conversation about how we can apply blockchain technology. I think these are some more interesting questions to be discussing right now. So we have a question here on the right. Sorry if I'm not seeing you, girl.
Two questions actually. How to apply the blockchain technology to education, for example, and how hard for the financial industry to create their own cryptocurrency instead of, let's say, Bitcoin.
Okay, so we'll start with your first question about education. You could have, for example, instead of me opening a College Board account and having to submit my SATs and ACTs and all of my school records, if I just create some sort of internationally recognized student account, I can have authorized institutions like my high school, like the College Board, send my grades to the network, and then instead of me writing a long application and picking who I want to send it to, I can just automatically, the university can just look me up instead.
Yeah, so they can access a private network.
It's not a private network. It's a public network that has encryption that certain parties can access and read.
Right. So it's private for certain people.
Yeah, but what it does is it could create this interesting way. Instead of, some universities might not have trust in the grades being submitted to them. Yeah. So if the grades being submitted to them have timestamps over 12 years that are irrefutable, then you could actually see, oh, these are probably his real grades or not. It would be specific to whatever that university or that high school is looking to do with blockchain. But the important aspect of blockchain is you have you need two things to create a record: an account and a piece of information that is attached to that account. So as long as you can think of any system that requires accounts or participants that are submitting information to the network that people might want to look up later, that's where you can see a blockchain application. You couldn't apply blockchain to a baqala or something like, let's say you wanted to sell your goods through a blockchain, you couldn't do that but you could use a currency which is on a blockchain. So there's certain things you can apply this technology to. So it has to have an account or some sort of participant and some piece of information linked to that participant. What was your second question?
My second question was how hard for the financial industry to create their own cryptocurrency?
Financial industry of fintech. So it's a very new technology. The development community for cryptocurrencies, the people are out there, but they're highly specialized and most of the time very secretive people. So to try and get involved in a cryptocurrency development space, you need to right now just know the right people. It's a kind of a luck thing. There is no sort of degree from university you could look at and say, oh, he can help me develop a cryptocurrency. No, you need a combination of network specialists, cybersecurity engineers, software engineers. These development teams tend to be a couple dozen people who are all extremely specialized, and right now this is considered research level work. So most of these people are also PhDs in their fields and how they're applying their field to this technology. I'm fine. Like if there's questions, we can keep going. Otherwise, we can go into informal discussion. One more question, if you want.
I would actually be interested about the application of the blockchain to logistics, for instance, as well. If you can think of anything that could be used for the logistics.
Logistically, it could be record keeping. For instance, if your DHL package has been to certain places, instead of having a timestamp, which a computer could be out of sync for or not recognize, you can confirm it in this sort of sequential recording system, which is the blockchain. If we look back a few slides. Because one more slide. So anything that happens here.
Actually, right now, DHL places all the events on the screen, and I can track it. But I hear that in the logistics field, we can actually get to know who is actually handling the.
Yeah, because for example, the driver with your package,
yes.
He would have to personally sign his, using his, so to checkpoint your package at certain places, certain people would have to sign with their accounts and post it to the blockchain.
Sure.
So and when it's posted, it becomes a matter of fact. Whereas if you're dealing with, I don't know, maybe their current system, where it's just the central computer and you don't really know who's using this computer to scan your package. True. So that's also another specific case analysis. The interesting thing would be, who are your participants? What you want to think about is who are your participants on the network? Everybody from the sender to the drivers to the receiver,
to the clerks,
and then what is your signature or what is your record? What sort of record do you attach to each account every time they want to post to the blockchain? And you can also see that this is not really, these things are not time sensitive. You don't have to sync up computer clocks. You don't have to sync up, any sort of time. Syncing up computer clocks is notoriously a difficult problem in networking. Sure. Whereas these sort of blocks are considered check marks. And the important aspect is anything that happens here must have happened after, so anything in 391 must have happened after 390. And the design of this chain makes the ordering irreversible and the traversal of the blockchain exactly one direction, exactly one traversal. You cannot reorganize these blocks, otherwise none of the cryptographic methods would be correct.
Excellent. Another question has to do with marketplaces such as Amazon and Alibaba. We know that blockchain could possibly kill them being the mediator between the seller and the buyer.
Which is what we talked about. If you want to think of market disruptions, and we go look at what a DApp is, what the definition I gave for a DApp. Come on, here. So this is exactly what a DApp is. It's an application that removes the middleman between users and providers. So you could think of Alibaba, Amazon, whoever, and then you think of your open distributed marketplace.
So what do you think? Are they afraid? Are they intimidated by the blockchain disruption, or are they going to join the...
Not something I can comment on.
You can't.
That's very opinionated. But definitely this would be in terms of the marketplace, in terms of what your, some sort of Amazon marketplace.
Yes.
This could be a disruptor or a replacer of it.
Could kill you.
Yeah, I gave the example of Uber. Instead of Uber facilitating all of your rider transactions, drivers price however they want, Uber riders put whatever they're willing to pay, and the network automatically matches you, or you communicate directly with maybe 3 drivers that you like, and the 3 drivers that you do like, if they're available, you automatically request them. If they're not, then you look at other drivers, and it could be some sort of, pick who you like, instead of, oh, here, Uber just gives you the first driver available. Sure. It becomes a more personalized, it makes a global market feel like a neighborhood level interaction.
True.
It would be like a bidding platform.
It could be a bidding platform. You could run an auction on a...
Because taking off the middleman, it will like remove the offering.
Exactly, and it could also, for example, make taxi companies competitive again. So if a taxi company offers a good service and they're pricing themselves competitively on the market, then people might half the time pick a taxi, half the time pick a private car. So it makes a completely open market that is as fair as your price. Your price fits the consumer's wants and needs, and he's willing to pay that. Then you're gonna go to him. It sort of pushes us back to Smithsonian economics. You have very simple price, supply-demand curves. Whatever the price is at, if people like it, they spend it. If people don't like it, they just wait.
I'm done.
Okay. Next question. I have a question up here. Oh, okay.
So my question is again on the future of these networks. So when the internet started, it started to decentralize everything, and then all of a sudden, as things progressed, certain players dominated certain aspects of the internet, and you have some sort of monopolies right now, like the big companies, the Google, Facebook, and other companies. So I know this is moving towards decentralizing and removing the monopolies of the internet towards more distributed networks. But moving towards the future, isn't the same effect? Don't you anticipate the same effect to happen with certain networks being the biggest players in the market for certain applications, rather than having a
I think
a
because
perfect world?
the cost overhead of starting a distributed network is not the same as an internet company. Internet company, database, engineers, headquarters and stuff like this. A distributed network can be started on people's laptops at home, and the developers don't even need to be in the same country as long as they communicate clearly.
Mm-hmm.
So to establish a distributed network can be done overnight with the right people, and then you're not incurring the same costs, you're not incurring the same logistical challenges. All you have to do is just have users participate. So there will not be any monopolization, because if people are, if there's, let's say there's a big network and a bunch of people are unhappy with it, then it will either hard fork. People will either begin to develop a new, there are many great engineers, many great software engineers who can't really do what they want to do in their field because of the amount of overhead that it takes to launch software or to launch a website. But if you can just, have people agree, have a dozen or 2 dozen people agree overnight to run your code, then you've automatically started a new network, and it becomes a gossip style expansion. You just tell your friends, and if they like it, they join it. It becomes a viral sort of a viral propagation, rather than advertise, and people register and stuff like this. A question up front. Any more questions in the back? One. Oh, sorry, I forgot. Okay, we'll move into informal discussion after this.
Oh, okay, so thanks.
Would you like me to change the slide?
No, it's fine. It's about dApps, actually. So recently we've seen, I don't know, some people have heard of the CryptoKitties infamous
Oh, yeah.
DApp application, which almost crashed the network, not crashed, but clogged the network. What can we learn from this, in your opinion? Because that was a very simple decentralized application, very simple way of actually transferring assets directly peer-to-peer. And it showed the strength of the system, but also showed some of the weaknesses from the transaction side.
The weakness that it provoked is one that we're currently tackling, and it's the scalability problem. Can we really achieve, let's say, every human on Earth, so there's 7 billion people, 24 hours, every human makes one transaction and average it over 24 hours. That's 50,000 transactions a second, which not even Visa is. Visa has a peak capacity of 100,000 transactions, but for very limited amounts of time. They can't keep it up for 24 hours. So this is a scalability problem. This comes with the immaturity of the technology. We have more interest, ideas other than block size and mining algorithms. We have ideas like off-chain transactions, Lightning. There's an off-chain technology called Lightning Network that's recently been launched. And it's going to be some combination of ideas, some combination of these technologies for their specific use cases. So for example, if you have, let's say you're a convenience store owner, you might want to use a Lightning Network with all the people in your neighborhood, and then once a week checkmark all the transactions and submit them. But if you're a ticket master, then maybe you want to use something, a different, you might need to just use a bigger block size to hold all of the transactions coming into you. So it's going to be some combination of new technologies coming up. What they are is still not solidified, but that's also the purposes of conferences like the one I went to a few months ago. If you go on YouTube and you search up Scaling Bitcoin 2017, there's a few very interesting talks about the scalability challenges and what we're currently doing. If you just put Scaling Bitcoin 2017, watch the keynote. It's really interesting. There's another speaker called Bobby Lee. He's the guy who ran Bitcoin China exchange from 2011 to 2016 when China closed down all the cryptocurrency exchanges, and they talk about what their ideas are for these scalability problems. There's also Joey Ito, who is the MIT Media Lab director. He gives a retrospective about internet's development, the internet's development and what we can learn for Bitcoin scalability.
Thank you. And my last question was actually regarding Ripple, because I just want to clarify, because Ripple is a private blockchain.
Yeah.
Bitcoin is a public blockchain.
Yeah.
So, and all the coins for Ripple are controlled by a company, which is actually Ripple.
Yeah.
So, do you think they are going to do almost like a private, decentralized network between the banks to accommodate? Because Ripple is just a technology to transfer money.
Yeah.
So, do you think they will actually, to be able to coexist properly, interact, and create some sort of a private, decentralized chain? Like a hybrid between those two. These
two.
Yeah,
yeah. It's interesting, but the one thing would be how much trust do you want to put in Ripple as a technology? Right now, the nice things that they're doing is they did open source their code, so you can actually check their security, prove that their code has no backdoor or no malicious intent. But that comes down to businessmen and what they want to do in terms of, because it's privately owned, the owner of that network, whatever his financial interests are, will probably dictate what will happen. So that's the only thing with dealing with private networks is, if for some reason it captures the market, then you don't want to be locked down and put into some sort of monopoly, which is also why adoption of Ripple is not as aggressive as some of the other cryptocurrencies. Thank you. Appreciate everybody for coming out and staying this long. Do we have more questions? We'll talk now.